Okay, so hi everyone. I will be presenting you an example, okay, which is more or less similar to the problem that I gave you for your quiz. Okay, so this one is a problem where the solution or the process of solving is the same, okay, or quite similar to the problem that I gave you for your quiz. So we have here a 6 kilogram piece of solid copper metal at an initial temperature T is placed with 2 kilogram ice that is initially at negative 20 degrees Celsius. The ice is an insulated container of negligible mass and no heat is exchanged with the surroundings. After thermal equilibrium is reached, there is 1.2 kilogram of ice and 0.8 kilogram of liquid water. Now, what is the initial temperature of the piece of copper? Okay, so first we have to understand the problem. So in problem natin, we have here a 6 kilogram piece of solid copper metal and a 2 kilogram ice. Okay, the ice is initially at negative 20 degrees Celsius. Okay, and then there is no heat exchange with the surroundings, and then we are assuming that the container is insulated and with a negligible mass. So we have there the copper metal and the ice together. Okay, tapos yung given lang natin is the initial temperature of ice, and then we are out to look for the the initial temperature of the copper. And then take note that we also have here when thermal equilibrium is reached, okay, we have left 1.2 kilogram of ice, okay, and then the rest or the 0.8 kilogram is liquid water. So yung ice natin, nag-undergo siya ng phase change na tinatawag. Okay, so from ice, it melted into water. Okay, yung 80.80 kilogram niya naging water. Okay, so to start with this problem, I will first write our given. Okay, so for the copper, we have here a mass, which is equivalent to 6 kilograms. And then we are going to look for its initial temperature. Now, we will assume that our final temperature is 0 degrees Celsius, okay, since that is the melting point, okay, or where the temperature, okay, or at 0 degrees Celsius, yung ice natin has the possibility to melt in liquid water. Okay, so since it is the freezing point of water, okay, or the transition of water to ice, okay, so at 0 degrees Celsius, there is a possibility that half or a percentage of the ice will become liquid water. So here we will assume that our final temperature is 0. Okay. So this is for both the copper metal and the ice. Okay. So also the final temperature for ice is also 0 degrees Celsius. Now for the ice, we have our mass that's 2. For the ice, we have here mass that is 2 kilograms. Okay, this is the initial mass of our ice or the mass of our ice when it is still an ice. Okay, so hindi pa yung naging 1.2 kilogram of ice na lang siya. Tapos yung 0.8 niya is water. So our initial temperature is negative 20 degrees Celsius. Our final temperature is 0 degrees Celsius. So here, we assume that our final temperature is at 0 degrees Celsius, or this is where the thermal equilibrium was reached. Okay. So at thermal equilibrium, we have 0 degrees Celsius. So that is our final temperature. Now at thermal equilibrium, take note that our ice Okay? Yung ice natin, naging 1.2 kilogram na lang. Tapos, nagkaroon na tayo ng water, which is 0.80 kilograms. Ayan. Now, here we are going to use, okay, the formula. So for copper, since yung copper natin, hindi naman tayo nag-change, okay, ng phase. Okay, so hindi siya naging liquid to solid or solid to liquid. Okay, so yung copper natin, we will only use our QMC delta T. That's for copper. Okay. Now for ice, since yung ice natin nagkaroon ng phase change, since 0.80 kilogram of our ice turned into liquid water, so nagkaroon tayo ng phase change na tinatawag. So we both have our change in temperature or temperature change and also our phase change na formula. We have MLF. Okay. Now, the next step is for this kind of problem, we have what we call the energy conservation or conservation of energy. So that's the same. Ayan. So when we say energy conservation, if we add the heat of the copper, total heat of the copper and our ice, it will be equivalent to 0. Okay. So that is energy conservation. So walang exchange of energy with its surroundings. So doon lang siya sa within the container or the insulated container, yung exchange of heat natin. So that is kung ano yung nawala doon sa copper na heat, yun yung nag-gain ng ice or vice versa. So that is what we call the energy conservation. So this is the formula. Okay. And then we will proceed with the solution or the solving. Okay. So for the solution, we'll start with the copper. Okay. So this is for copper. Okay. For copper first. Ayan. So Q is equal to MC delta T. Okay. Now our mass is 6 kilogram. Okay. Our specific heat for copper, that is 300. Sorry, I didn't write it, or I haven't included it in the given. Okay, but the specific heat of our copper is 390 joules per kilogram degree Celsius. Ayan. And then our delta T is our final temperature, that's 0 degrees Celsius minus our initial temperature. Okay, so if you have noticed, wala akong sinulat na value for initial temperature since yan yung hinahanap natin dito sa problem. Okay, the initial temperature of our copper. Ayan. Okay. So I will write it as is. Okay. So kung 0 degrees Celsius minus negative T, we will be left with negative T now. Okay. So if we will solve this using the calculator, we will obtain negative 2.34 times 10 raised to 3 joules per degree Celsius times our T naught. Okay. So bakit nagkaroon ng negative? Take note that this is minus. So 0 minus T naught, that will be negative T naught. So we now have the value or the equation for the copper to proceed with the ice. So sa ice naman, we have both change in temperature and change in phase. So our total Q here, we have the MC delta T plus the MLF. So our mass here, this is actually our mass for ice and then our mass for the liquid water. Okay, so yung initial mass natin for ice, that is 2 kilogram. times our specific heat for ice, we have 2,100 joules per kilogram degree Celsius. And then our final temperature minus initial temperature for our delta T, our initial, that's 0 degrees Celsius, okay, minus negative 20 degrees Celsius. So if you have here minus minus, this will become positive. Okay. And then we also have plus MLF. Okay. Now here, ang ginamit natin or ang gagamitin natin is the mass of the water kasi nag-change naman tayo ng phase. Okay. So during the phase change, we obtained 0.80 kilograms of water. Okay, and then times the latent heat of fusion for the water, that is 3.34 times 10. That's 3.34 times 10 raised to 5 joules. So if you calculate this using your calculator, you will obtain 3.512 times times 10 raised to 5 joules. Okay. So sorry, I forgot to write. This is Q copper. This is Q ice. Now we'll go back with our energy conservation formula or an equation. So for our energy conservation, we have Q copper plus ice plus Q ice is equal to 0. So I can write this as Q copper equal to negative Q ice. Okay, now if we transpose this positive Q ice to the other side, it will become negative. So kaya naging ganito. So mawawala na yung 0. Ayan. Now, I will write the value that we obtained. We have negative 2.34 times 10 raised to 3 joules degrees Celsius T naught is equal to negative 3.512 times 10 raised to 5 joules. Ayan. So, transposing, okay, when we say transpose, kailangan yung matira sa isang side is si T naught lang. Kasi yan yung hinahanap natin dito sa problem. Okay. So I will be dividing both sides by negative 2.34 times 10 raised to 3 joules. Para makancel siya dito na side. Okay. So we also have here 2.34. So para yung maiiwan na lang o yung matitira is the T naught, okay, or the initial temperature, which yung hinahanap natin sa problem. So ayan, cancel out. We have now T naught is equal to negative divided by negative, that will give us positive. So this is actually 150 degrees Celsius. Now this is our final answer for this problem. Okay, so now for this problem, okay, we have here, this is the number one, or the item number one for quiz. In a container of negligible mass, 0.2 kilogram of ice at an initial temperature of negative 40 degrees Celsius is mixed with a mass M of water that has an initial temperature of 80 degrees Celsius. No heat is lost to the surroundings. If the final temperature of the system is 20 degrees Celsius, what is the mass of the water that is initially at 80 degrees Celsius? Now for this problem, what you're going to look for is your mass or your mass M. So dito yung hahanapin ninyo is si mass. Dun sa example na binigay ko, what we look, yung hinanap natin doon is temperature, initial temperature. Now here you're going to look for mass. Okay. You will also use the energy conservation or conservation of energy dito, where you will have the heat for water plus heat for ice is equal to 0. So, itra-transpose niyo yan, where you can have M at the left-hand side. Tapos, makukuha na ninyo yung formula ng M from this relationship or from this formula na energy conservation natin. Okay? Now, what else? So, for Q water, so since hindi naman tayo nag-change ng phase for water, yung initial natin na tubig at the end of, or at the final temperature of the system, which is 20 degrees Celsius, tubig pa rin siya. So wala siyang phase change na pinagdaanan. So you will use the MC delta T. Now for Q ice naman, so you will expect that your ice from negative 40 degrees Celsius to 20 degrees Celsius, it will also turn into water. Okay? Kasi na-pass through niya na yung phase niya, that is from solid to liquid. Nagiging liquid na siya at 20 degrees Celsius because 20 degrees Celsius is higher or more or less hotter doon sa ating freezing point ng water, which is the 0 degrees Celsius. So you will use two formula, or you have here your formula for temperature change and your formula for phase change. So MC delta T and then the ML. So what you are going to solve now is, or what you are going to look for in the problem is itong M na ito. Kasi yun yung hinahanap, the mass M. So, ayan siya for example number 1. Now for the example number 2, we have here a 2-liter pitcher of lemonade has been sitting on the picnic table in the sun all day at 33 degrees Celsius. You pour 0.24 kilogram into a styrofoam cup and add 2 ice cubes, each 0.025 kilogram at 0 degrees Celsius. Now, assuming that no heat is lost in surrounding, what is the final temperature of the lemonade? Letter B, what is the final temperature if you add 6 ice cubes? Okay, now for this problem, what we're going to do is the same. We will still use our energy conservation, or conservation of energy na relationship, where heat loss is equivalent to our heat gain, or heat gained by or the heat of our lemonade plus the heat of water. I'm sorry, that's the heat of ice, not water. It's equal to 0, or QL is equal to negative TI, or pwedeng baliktad. Okay, and then here we are going to look for the final temperature of the lemonade. So let's say our lemonade did not undergo change in phase. Okay? So yung lemonade natin from the very start is still lemonade. At the end of the day, it's still lemonade. Hindi siya naging solid. Okay? It's still liquid. So MC delta T lang yung gagamitin. While our ice, okay, yung ice natin, nag-undergo siya ng phase change since from 0 degrees Celsius. Okay. Pag nilagay na natin siya doon sa lemonade, okay, and then the heat, okay, during that time is at 33 degrees Celsius, yung heat ng surroundings. So may possibility na mag-melt talaga yung ice. So we are going to use MC delta T plus MLF. Okay, for the ice. And then what we are looking for in the problem for letter A is the final temperature. Okay, final temperature of the lemonade. So take note that our delta T is equivalent to your T final minus your T initial. Okay. So itra-transpose lang ninyo na TF yung matira doon sa isang side. So this is quite similar to our example where yung hinanap lang natin is the initial temperature. So instead of initial temperature, yung hahanapin naman natin dito is the final temperature. And then take note for letter B, so what is the final temperature if you add 6 ice cubes? So dito, we only have, for letter A, we are going to solve for the 2 ice cubes. So yung 2 ice cubes natin, we have 0.025 kilogram each. So if you multiply ninyo yan, so for 2 ice cubes, you will probably obtain 0.50 kilograms. Now for letter B, since meron tayong 6 na ice cubes, so you multiply it by 0.025 kilogram and use this as your mass for the ice. Okay, for letter B. Ito yung mass for the ice natin for letter A. So I hope nabigyan kayo ng understanding doon sa kung paano isolve yung problem. If you have more questions or more clarifications, you can ask me. But I suggest na if you do your quiz or you do your activities na just do your best. Okay? So kapag hindi na kayang intindihin, kapag hindi na kayang isolve, it's okay. That's okay. So you just write or you just write the solution or solve the problem in a way na naintindihan ninyo. Okay? So not necessary or hindi naman kasi kailangan na dapat tama parati. Okay? Dapat tama parati yung sagot. But as long as you put an effort in understanding the problem, kapag nakita ko naman yun, so meron pa rin corresponding points for the effort. Okay? So not necessary na dapat tama parati yung sagot ninyo. Although you cannot obtain the perfect score or the yes or the highest possible score, okay, but as long as you have tried okay, calculating or solving these problems, okay, as long as you did not copy, okay, or hindi lang kayo kumopya dun sa mga kasama ninyo, na pare-parehas yung solving ninyo, ganyan. So, that's okay. Okay, so I will understand and I will also consider. So don't worry, we also have a lot of activities or a lot of quizzes and assignments na pwede kayong bumawi. Okay? If ever you are worried, okay, kung worried kayo dun sa magiging score ninyo or magiging grade ninyo. Okay, so that's all for today. Thank you everyone for watching this video and for listening. I hope you understand the topic or you understand the process of solving this problem. If you have questions, clarifications, okay, and suggestions, please don't hesitate to send me a message, but send it during our working hours. Okay, so para ma-entertain ko siya. Okay, thank you everyone. Goodbye. God bless.